Okay, welcome to the last video for 13.4. I know the examples are a bit more complex, but this is the last example already. So now, okay, there's this police car and a taxi. So this is found on page 41 of your textbook itself. So there's a police car and taxi traveling in opposite directions. They approach each other. Then they are at a perpendicular distance of 36 meters apart. So that means over here, okay, it's 36 meters. Then there's this x meters, okay, is a horizontal distance, and s meters is the diagonal distance. So the first thing we notice, it forms a right angle triangle. See, it's so nice, they help you to label there's a right angle triangle. So what they want you to find is if s is decreasing at a rate of 40 meter per second. So what I know here is rate of change of s with respect to time is negative 40, okay, and when s is 164 meters, this one is just 164, find the rate at which x is decreasing. So I rate of change of x with respect to time, like this. Okay, so now what I can actually try to do now is this. I can try to create the equation. So I know I have a rate of change of s with respect to time. I have a rate of change of x with respect to time. If I look at it, right, actually I can try to form an equation involving s and x, okay, so that what I can do is that I can differentiate s with respect to x to get ds dx, like this. If I'm able to do this, I can actually form out my equation, and using the chain rule I can get this. ds dt is equals to, you differentiate s with respect to x, and again, bad mathematics, but it helps you to form the equation. If you eliminate x, okay, what you get is ds dt. That's why this equation actually pans out. Okay, now what I need to do first is this. I think ds dt we have, okay, is negative 40. ds dx I don't know, I need to form the equation, and then dx dt is what we need to find. So this is our main problem first. So what I can do is this. This is a right angle triangle, so I can apply Pythagoras' theorem, whereby s square equals to 36 square plus x square. So s is equals to square root of 36 square plus x square. So if you remember from above, we need to differentiate s with respect to x. So if I differentiate this, okay, I can bring down the power, half, bring down 36 square, okay, plus x square, then power half minus 1 is negative half. Differentiate inside the bracket, I get 2x, like this. So if you simplify everything, what I get is x over square root of 36 square plus x square. So I've already found the expression for differentiating s with respect to x. So let me just copy that down now. Let me try, okay, to copy this. Okay, so earlier what I've already said is this. The chain rule gives us this is equals to this times rate of change of x with respect to time. So now ds dt, as we have spoken about earlier, is negative 40. So I just substitute that into the value. Negative 40 equals to differentiate s with respect to x. So it's x over square root of 36 square plus x square multiplied to rate of change of x with respect to time. That's what we want to find. So I do know, okay, that what do I know also? I know that the x value, okay, is equals to, let me calculate the x value. Okay, notice that I still need my x value. So how do I find my x value over here? So if you look, right, there's this point in time when the s value is equal to 164. So if this is 164, by Pythagoras' theorem, x is equals to 164 square minus 36 square, and I square root this. And in this case, my x value will be equals to 160. So if I just substitute in all the values, here's 160 divided by 36 square plus 160 square multiplied to the rate of change of x with respect to time. So if you use your calculator, then you work it out, you will find that the rate of change of x with respect to time is equals to negative 41. Negative 41 implies that x is decreasing, this negative, at a rate of 41 meters per second. And that's it. And this is the